Right, we are live, and today is Technical Thursday, and we're talking about medium voltage applications. We got Ryan Jackson in the house. Hey, we even got David Williams. So appreciate everybody dialing in. Larry's not with us yet. I'm not sure where he's hanging out, but he's probably on some task group work. But he says he's going to show up. So we're going to have hopefully Larry Air on tonight. And we are going to be talking medium voltage. So hopefully we've got my sounds good. I got to just take a look, make sure I've got, I got to get my audio mixer up. There we go. All right. So I'm getting audio. That's a plus. Welcome, everybody. So it is the 12th, and today is Medium Voltage Thursday. So we're going to be talking medium voltage. And we're probably going to go for about an hour, I would think. Probably not going to hit the whole 2 hours, but remember to subscribe, hit the bell, and get notifications, all that good stuff. And so today is going to be, let's talk about, let me get my, make sure I got my stuff here. So, PT wide, I think. Yep. All right. So this is our medium voltage discussion. Okay. So if you may or may not be aware that the 2023 cycle saw a bunch of public inputs around specifically medium voltage, looking at trying to help provide clarity and whatnot to the National Electrical Code with regard to medium voltage applications. So the way the NEC is laid out at this point right now, the way the NEC is laid out, there was a task group done a while ago, and I know that I believe we got Tim Krauscher on watching here too. He chaired that task group a while back, and what their focus was to try to address the medium voltage, and medium voltage was at that point all in one article. And what they did was they ended up putting all of the medium voltage requirements into the different articles within the National Electrical Code. So you have in Article 210 for branch circuits, there are some medium voltage. Grab my book. There are some medium voltage requirements in Article 210. Not a lot. I think there's like one or two areas in 210. But when you get into feeders in Article 215, we've got some more delineation with regard to medium voltage in 215. I believe there's a few areas in here that speaks to medium voltage, but as you get into like 230 and other articles, there's actual parts like we'll talk. Well, hold on. I think I got Larry's dialing in. So let's give me 1 second here. Larry, are you there? Can you hear me?
Yeah, sorry about that.
Hey, not a problem, brother. Let me get you set up. So everybody out there, I am just going to get Larry set up here. So hold on, Larry. I'm going to get you. You're cutting off the top of your head. Can you lift your camera up a little bit? Oh, there you go. You were frozen. There you go. All right, so let me hold this Alt key down. And I will do this. Now you're going to see a little bit of doubles, so apologize for that, Larry. All right, let's do this. Two of us. There we go. So let me get out of studio mode. All right, so Mr. Larry Air, thanks for joining us. And we got started, and all I did was I sort of was just giving a little introduction with regard to medium voltage, the fact that medium voltage at one point, I can't remember. Do you remember the year that the initial task group went into effect that basically took one article in the National Electrical Code and peppered the requirements for branch circuits, feeders, and cables and whatnot throughout the NEC, right?
And I think that might have been 1999, and I see that Tim Krauscher is on there, so he probably knows exactly what year that was.
Yeah, yeah, and I remember he sent me a note about that, and I was going to try to get him on, but he had some I think he's probably driving somewhere right now. We were all tied up on calls today, and as I know you were. So in any case, so what I did was I grabbed some of the documents with regard to what do you call it? Some of the public inputs that were made for the 2023 cycle. So I thought maybe we could have a discussion around a couple items, specifically around. Hold on. Nope. Jeez, oh man. I've got the wrong screen up there. I got display 1. I don't want display 1. I want display 2. There it is. So we were going to talk about a couple things. First off, medium voltage, low voltage, high voltage. What's the cutoff? I know in the end, the National Electrical Code used to have the low voltage associated up to 600 volts. And then over the last 2 cycles, I would say, they moved that 600 volts to 1,000 volts. So in the NEC, is anything above 1,000 volts medium voltage, right?
Correct. And I think that there's various things in the code. You'll see things that in 490 talks about high voltage, and this discussion took place today on panel 9. And I think throughout the industry, I think high voltage is probably considered somewhere the delineation between 35,000. I think that's the demarcation. So below that would be medium voltage, and above that would be high voltage.
All right. So 35,000 volts is your high voltage. Now the code doesn't speak to high voltage though, right?
Well, the code does reference high voltage in certain areas, but I think when they use the term high voltage, I think, they're talking really about marking. And when they talk about marking to say, hey, stay out, danger, high voltage, I think it's more to the fact that they want non-qualified people to know there is higher voltage than normal. So I think, and that was discussed today in panel 9. So I think that is more towards a marking requirement and not necessarily in the NEC to delineate about equipment.
Right. So in the NEC, we're talking installation requirements. So you're thinking about conductor ampacities, calculating load currents, providing overcurrent protection for conductors, medium voltage conductors. And I guess it would probably, when you get into medium voltage, we're using relays, right?
Correct.
Yep. So in the medium voltage world, you're talking a lot of the, what do you call it? In fact, my best reference that I like is the Protective Relaying Handbook from Blackburn. I don't know. Do you have this book, Larry?
Yes, I do. It's a
good book. And in there, they have all of the different relay numbers from, synchronous check, isolation. They've got overcurrents, 50-51 relay. So a 50 relay is an instantaneous overcurrent. 51 is AC time overcurrent relay. All of those translate into overcurrent protection and whatnot. So, so that, and in that world, we're still doing overcurrent protection. We're still protecting the conductor. It's just we're doing it with relays more so than thermomagnetic circuit breakers.
Correct.
All right. So what if we talk a little bit about some of the public inputs? I went and I have a sort of overview of where the head of, there was a task group associated with this this effort, right? So that was led by Robert Osborne from UL. Is that right? Yeah.
Correct. And Robert has done he's done tremendous work on this task group, and we really have some significant number of people on this task group that have a tremendous amount of medium voltage expertise.
And that's critical because this whole topic and discussion is a lot different than it's a lot more different than your standard systems, right? Because medium voltage is a considerable difference from your low voltage applications, from a spacing requirements, from how we do protection, working distances, and things like that. So
Yeah, it's really quite interesting when you really sit there and look at it. The code has been set up, and I've mentioned this numerous times now, but the code is set up when you think about it from 1,000 volts and below. We think about terminations 60, 75, and 90 degrees. We think about when we do things for 1,000 volts and less, we talk about 80% rated breakers. Now, there are some breakers that are at 100% rated. Those are typically in the higher level ampacities. We talk about grounding. Grounding is 250.122 based upon the overcurrent device. It's 250.66 for services. And so we have these common themes, but really in the medium voltage world, it's a totally different ballgame. We have 100% rated breakers. Everything there's 100% rated. We have terminations that are 90 and 105. We have shielding of cables. When we talk about grounding, we're really not talking about 250.122 because those breakers typically they're not going to trip instantaneously. They might be a 30 cycle breaker. And so we have to make sure that the grounding is rated to handle that fault current and maybe the slower response time. So it's a total different animal. And sometimes I think in the NEC, we have requirements that are being put in there based upon people's experience at 1,000 volts and below. And so we're trying to try to change that mindset and try to get people to look at it differently.
Yeah. So the task group I have here, this is from one of the public inputs that I'm not sure which one it is. This is actually chapter 3. I think you say I know you wanted to talk a little bit about chapter 3, but they put in a Word document so anybody could go out to Terra to look at the next version of the National Electrical Code, and you can download the it's a global public input. There were various global public inputs. So you're not going to go to Code Panel 3's work or go to Article 3, Chapter 3 in different articles and find these public inputs. You've got to go down to the globals, which maybe later on I can show how to get to that. But there's a Word document attached to the public input. And it tells you that it was a Correlating Committee Long Range Planning Task Group. Now, Larry, when you want to speak to the long range aspect, I know that there were various long range. I was participated in one, which was the photovoltaic or the alternative energy effort. But when they say long range, what do you mean by that?
Well, I wanted to, I've been lucky enough and fortunate enough to be appointed chair for approximately 9 years, so 3 cycles. So I wanted to look at things from a long-term approach, and I think there's certain areas in the NEC that need a little more consideration, and based upon the way the electrical industry is moving. If you look at the way the industry is going, there's more and more limited energy being developed. There is more use of computer cables, power over Ethernet, a new technology called pulse energy transfer. You see that there's a lot of renewable energy and things like that. And those are a couple areas that I wanted to concentrate on. And, it's difficult for people to put in, to try to change requirements 2 weeks out of 3 years. And so I wanted to put together groups that would work on these things constantly 3-year period. So we can make sure that we keep the NEC relevant. And so that's part of what we did with the medium voltage. We wanted to make sure that we put together a group to say, okay, let's see what are the issues in medium. You see more things happening with maybe, actually there are some substations that are owned by customers. You have with deregulation. Deregulation has picked up speed in the last probably decade. And so more stuff is being turned back to the building owner, maybe because of cost considerations. So because of these things, we think there's a more tremendous need to look at the NEC and make sure it's relevant. So that's why we want to do this over a long term.
Yeah, so I know a lot of people have the misconception that medium voltage is a utility thing, where in reality there's applications where you have medium voltage in the private sector, either owned by an industrial or commercial. So you have a design firm, right? So you're laying out systems. When do you make the decision to go to medium voltage?
I think I think it always depends on size. If they're you start getting above a 4,000 amp service, but I think like 480 volt, you really start to need to look at medium voltage. And sometimes if you do tremendous runs, tremendous length of runs, um, I know this sounds weird, but we just got done doing a 30,000 square foot residential dwelling. And so because of that, this dwelling was over maybe 60 acres. And so what you had to do is you had to get the utility from the front to the back of the property. So maybe the length of the run requires that. Sometimes you end up with municipal parks and things like that where there's significant acreage, and you want to make sure that you distribute the voltage at various levels in the park to get the
You're breaking up pretty bad.
I think there's various reasons why you do it, and I think sometimes you have huge industrial complexes that might be 1,000,000 square feet, 800,000 square feet, and so I think some of those times that's where you need to look into this thing.
Yeah.
All right, give me 1 second and keep talking there, and I'll get a better connection.
All right, cool. Even so, L is pointing out that even a fairground can own their own medium voltage system. Now, I can recall talking with a gentleman by the name of Donnie Cook, Shelby County, Alabama. He saw medium voltage in around ball fields where they would bring. Actually, it was even higher than 4160, 4,000 over 4,000 volts. They would bring the medium voltage around the ball field and then step down in smaller substations. So from a when do you use medium voltage equipment perspective, I agree with Larry in that it's all about when you have distance involved with it, when you have applications where you have where you're dealing with trying to take and voltage across a campus, because you've got to think about voltage drops. And when I have lower voltage drops, my conductors are larger. When I've got medium voltage, I'm typically pushing lower currents across the line, and I am working on smaller conductors, but my equipment gets a lot bigger. So that's the other aspect of the whole picture of medium voltage applications, right?
Can you turn off that TV?
All right. So I'm gonna mute that while he's getting set up. All right. All right. So I already mentioned the book. Now, if we look at this, I'm going to put up screen number 1, which is this is the public input. So when we talk about the public input, we get a new public input. We get substantiation that basically gives you an overview. Like, this is the task group work. So this task group was put together and was chaired by Robert Osborne. Paul Barnhart was on there. He's UL. Lou Grayhor is an Eaton gentleman. Donnie Cook is on there. And now Donnie Cook, again, Donnie is passionate about medium voltage. And the reason was because he has a lot of applications that deal with medium voltage. So if you look at the application, and this is part of their substantiation. So you're back, Larry, right?
I'm back.
All right. I'm going to see which one. I think this is it here. Yep. All right. So, and I'm just going to move you just a hair. I'm going to move you down a little bit. There you go.
And Tom, is that 305?
I think this is the substantial. Yeah. So this is the chapter 3 changes. And what Robert did was put together the overview of what they did in chapter 3. And so they have Article 300 is remaining a general requirements for the wiring methods. So there's no change to that. And I believe what they're doing is their thought process is to pull all the medium voltage requirements out into their own articles, right? So where we had a mix of public inputs or a mix of requirements in one article, they're pulling out those requirements and putting them in their own article. So Chapter 3, Article 300 is not getting changed from a general requirements perspective, but all of the 1,000-volt application stuff is being pulled out into Article 305.
That's correct. And we're doing several things. Some of the things we're doing is so, for instance, 300 is a part of code making panel 3, and 300 is broken up into 0 to 1,000 volt requirements and requirements that are over 1,000 volts. And so we are looking at that because a lot of times in CMP3, they're dealing with a lot of limited energy stuff. So we're trying to break that out to put more focus on that. We're also trying to take, if you look at Article 490, 490 has a tremendous amount of overcurrent devices and overcurrent protection items in 490. So we're trying to get things really where they belong. So 490, we're going to take some of those requirements and merge them with the medium voltage in 240 to create an Article 245. So we're going to do that. And then if you also think about that, we're also taking Article 210, 215, 225, and 230. There's very little medium voltage requirements in those sections. So if you think about it, we only have in 210.6, we have one section in there that specifically deals with medium voltage. And it's a very generic requirement. And if you look at Code Making Panel 2, Code Making Panel 2 deals with receptacles, arc fault receptacles, arc fault breakers, the placement of receptacles in dwellings, and things of that nature. And so what happens is to put medium voltage with that group might not be the best thing. So we're trying to take the branch circuit feeder and service conductors for a medium voltage area and put them into 235. So and then you also look at the marking requirements for medium voltage. Medium voltage is marked totally different than what we would do for standard building wiring systems. So we're going to split off 200 into 200 and 205. So you'd have 205, 235, 245, and then you'd end up having grounding. We'd split that up to 255, and then you'd have a 305. So those are things to try to get people to focus on those topics that we improve the technical content in those areas.
All right. So now I noticed that they've established 1,500 volts as that DC level. So AC 1,000 volts and DC 1,500 volts. That's
right.
new.
And there's kind of a thing out there where if you look at Article 311, 311 talks about medium voltage cables, and 310 talks about general conductors and cables. And so when you talk about 310, 310 is really cables and conductors that are 0 to 2,000 volts. If you go to 311, it's above 2,000. And I think part of the problem is that UL standards have created that 2,000 volt threshold. But the reason we went there and we changed that from 1,000 volts AC to 1,000 volts AC and 1,500 volts DC is more and more things that nowadays are going DC, and a lot of photovoltaics are around that 1,500 volt DC area or less. So we wanted to make sure that people realized that this is strictly not an AC issue. This is both AC and DC.
Yeah. I think it's Robert pointed out. He says medium voltage systems with MID, MIDs, PCSs, 10 apartment building, residential, solar, generators, energy. Medium voltage is medium voltage regardless of where it's at. To your point, Larry, 1,500 volts and higher, we're seeing the alternative energy, the PV systems, they're pushing the voltages up higher for a lot of different reasons. And pushing the voltages up will bring the currents down, right? So I can use smaller conductors to get the job done. And smaller conductors bring lower losses. So you would think it's more efficient of an energy transfer, right? Which is probably why photovoltaics is.
And also too, I think that, again, it's for longer length runs, for bigger areas, huge industrial plants. Maybe you have, a significant large size PV system. So it's becoming more common.
Yeah. So I have a slide over here that talks about the different options. You may put that up there that sort of lays out the different 7 chapters and where to 2020 is, and then moving in.
Sure.
All right, let's just do that. All right, so this is the 2020 code, how it's laid out. You'll notice we have, obviously, you have Articles 100. Article 100, there's medium voltage terminology in there as well, right? 110. Is 110 is separated into medium voltage, right?
Right, and 110 has the same issue as Article 300. There are a limited amount of things in Article 110 that deal with medium voltage, and we're trying to improve that. So we thought by splitting that up, again, that would provide more focus in on medium voltage areas.
Yeah.
Specifically 110.14 really talks about terminations on 60s, 75, and 90 degrees. And so it really doesn't mention 90 and 105. So there's some issues there that we'd like to explore.
Yeah, and like we said, medium voltage equipment is listed differently. It's rated differently. It's 100% rated, so we don't do the same type of readjustment of ampacity and whatnot when we're terminating in medium voltage equipment.
And the other thing you see that a lot of times what these code picking panels do is because they're geared towards that 1,000 volt and lower concept, they typically take those requirements and they will mark up conductors 125%. And they do that because they think they're always in that 80% breaker world.
Right.
And so they apply those concepts continuously to feeders and things of that nature in like 215, I think, 215.21 or somewhere around there. They take those concepts and they apply them when you don't really have to do that.
Yeah, because the thought process is 1 through 4 applies generally and whatnot. So a lot of people just think that because it's in one section that it automatically applies to medium voltage, and especially if the medium voltage world is silent on it in the code, which I think is another problem in the code, is that when there's silence in here on certain topics that we're typically used to dealing with, we apply the rules for the 600 volts and less in those medium voltage applications, to your point.
Right. So, for instance, you take Article 230. 230 talks about service conductors. They talk about clearances. They say, okay, these wiring methods, when you bring overhead conductors to a building, here's the height they need to be above alleyways, roads, sidewalks, and things of that nature. If you try to find that same information for a medium voltage application, it's silent. There is no information to find. And so what happens is I think some people tend to get lost and they might go over to the NESC. Well, the NESC doesn't really deal with customer-owned equipment or installations. And so there's a disconnect in some of these areas. And that's what we're trying to fix. Some things you see that, and these are some of the technical issues. If you go to Chapter 3 and you look at 300, it talks about burial depths. Burial depths of a 35 kV cable talks about that you can bury that in rigid.
Uh-oh, we lost him. I heard a crash, and then we lost Larry.
Yeah, that was a crash. That wasn't me.
Okay. What was funny was we heard the crash, and then all of a sudden you just froze.
Well, I think my wife's trying to tell me to be quiet.
Oh, okay. You got the direct burial, and then we lost you.
Yeah, so now the direct burial is the fact that, we have some requirements that are in the NEC to bury 35 kV cables at 6 inches, and that just doesn't seem accurate. The NESC is at 42 inches. And so we have some technical things that just don't fit, and we got to figure out how to make those better.
Right. So this is how the National Electrical Code is laid out right now in the different chapters. And I guess this task group went through 3 different options on how to deal with this, right?
They went through about 7 options, to
Is
be
that right?
honest with you, and they looked at a whole bunch of things. There was recommendations on trying to put information in an annex, telling people, hey, maybe if we tell you where the stuff is located. They went through some things about maybe adding code making panel, medium voltage experts to each of these panels. And if you did that, you didn't think about this. If you had to add 3 or 4 medium voltage experts to each panel, you might end up to add 30 people. And so you would only have people on the code making panels that were only there for, maybe 10 to 20 public inputs, and then they would have to sit through some other things that they might not be that knowledgeable about. So there was some talk about moving everything to a 1 chapter. There was significant input on trying to get that done. That was the second option that people liked. But the one they thought that would be the most useful at this present time is to do the one that you see on the screen.
That's this one here where they're creating Article 205, 235, 245, 255. So I see a trend.
Yeah, and the trend would be that, if you were a user of the code, anything that ended in a 5, you could say that that's considered wiring methods or requirements that are above 1,000 volts. There was some method and thought put into this.
Now I know that as they went through the code requirements around medium voltage, they found some technical inaccuracies or some things that were missing. To your point about the depth and whatnot, it's my understanding that what this task group's approach this cycle was to simply get a reorganization for clarity. Is that right?
Well, that's correct. They basically looked at, let's get it a structure that we think that long term will help us improve the content. It will allow us to put more eyes on the problem. It will allow people to submit more public inputs to this and make it more relevant. And they did have some individuals that saw some of these technical challenges, and they did submit some public inputs on their own.
Okay. So there are some technical items that are going to get on the plate around medium voltage, but this task group is looking at reorganization. That's not to say that the task group might also. I would hope that the task group would pick up some of those technical changes because, like you said, this group is full of medium voltage experts.
That's correct. We had people from the university systems, from the University of Wisconsin. We had people that were utility folks. We had inspectors, and a lot of times you hear the inspectors are the ones that are saying that it's a problem. These inspectors are getting into areas where they're turning over medium voltage to the owner, and they have to go out and inspect it. And they're trying to figure out, how do I inspect this? Is there? I don't see any requirements in there for clearances. I see very little information on listing requirements. And so I think they become lost on trying to do some of these things. And so this is, again, to bring the code forward. And, if you look at what's happening in the industry, a lot of things are there's a big push for low voltage cables up in chapter 7 and 8. And we want to make sure that that's relevant. And we want to make sure that the medium voltage is relevant too. So we want to make sure that inspectors are around for a long time. So we want to make sure that we solve these issues in the NEC.
All right, so we got a couple questions. Chris Folan asks, is deregulation and demarcation the same thing? What do you think about that?
Oh, I think that's a good one for Tim Kraushaar that's not on the call. So, or maybe he can weigh in. I think that deregulation is not demarcation. I don't think it's the same thing.
Yeah.
I think if you look over the time with deregulation happens to deal with the fact that, you've got this 3-legged stool of generation, transmission, and distribution, and it's really breaking up the generation and transmission from the distribution. So it's splitting out those 3 things and putting them in 2 buckets. And so what has happened is that the utilities, they can't do everything for free anymore because they had all three buckets. Now they only have two distinct buckets and they lost one of them and there's more competition. So now they can charge the customer more and more money to install new services. So when they do that, that's where the customer says, maybe I will take over the medium voltage and maybe it's more cost advantageous to me to install it. And so demarcation is really always kind of stayed the same. Demarcation is where the utility stops and the premises wiring begins.
Right.
And so that demarcation really hasn't changed over time, in my opinion.
Yeah. Now I think some would argue that that line of demarcation between the utility and the owner is sometimes a gray area, you know, and debated and discussed based upon from application to application, which presents different types of configurations. So, but now the National Electrical Code doesn't apply on the utility side. They use the NESC, obviously. So that's why that line in the sand, so to speak, is really critical and important for inspectors and for designers and contractors.
Correct. Yes.
Well, Tim Krauscher gave you the thumbs up.
Oh.
You see that? He says, "Good answer, Larry." So yeah, that's good. That was good.
Sometimes you get lucky.
Yep. And Al says we call that a service point in the code.
You know, we're trying to do similar things. I know this is a medium voltage discussion, but we're trying to do similar things. You know, deregulation has also really changed the communication industry. And so you look at that, it's not just Ma Bell and the communication companies installing cables in a home. You know, it used to be Ma Bell would come in and wire your whole home with phones, or the cable company would come in and wire your whole home with cable TV. Deregulation has changed all that, and so we're also trying to look at something called the communication service point up in Chapter 8. We're trying to delineate where the service provider or communication company starts and stops, and then where the actual other contractor starts. So we're looking at those both items. So they both have to do with deregulation, but demarcation probably more so in the communication industry now.
All right, so we're going down the list. Mr. Ryan Jackson's in the house. His question is, and it's along the lines of, you know, you were explaining about adding people to code panels, and they took this option with creating a 205, a 235, etc. His question is, will this result in a new code making panel in the future, or will the individual code panels keep purview?
You know, I would love to hear what Ryan thinks and other people on that. That's a really good question. I think there are code making panels out there that have great expertise as far as maybe medium voltage. One of those, for example, is probably code making panel 5. A lot of people on there that have really good experience. I think if you look at code making panel 2, as I talked about before, they probably don't have the medium voltage experience given the fact they deal mostly with GFCIs and arc faults. If you go to panel 3, they deal a lot limited energy, so they probably don't have the expertise. And so each panel is a little bit different. So I could envision that some things would be given more to like a panel 9, who takes care of medium voltage equipment and has a lot more people on there geared toward the medium voltage environment. But I could also see some panels retaining their purview.
Yeah. Yeah, that makes I mean, I can see different panels, but like you said, the expertise on the panels will vary considerably.
And I think, you know, Ryan just mentioned there, he thinks a new code making panel would be the best. And, you know, I'd probably agree with him. You know, I'd probably agree with him, but I'm only one voice, and it'll be interesting to see how that turns out. I know that the medium voltage task group thought that that would be the best option if we did it that way.
Is that right? That's good to know. Now, another individual says about plans reviews. You know, when you're looking at drawings and one-line diagrams, there's a whole nother topic. You know, when we think about documents, right? I'm just trying to find here. Now, when you have, let's try this. Medium voltage, you know, when we talk about like one line diagrams and whatnot, in the medium voltage world, there's a lot of details associated with relays, right? One line diagrams for the for somebody who's familiar with less, 600 volts or 480 volt systems, those diagrams are a lot different than your medium voltage applications, because in medium voltage we do a lot more of relays. So you'll have, I'm looking for a good diagram. I know we got some in here where you have different, you'll have the designations are a lot different. The relay symbols will that's still low voltage there. So they're either fusible equipment. There's a lot of fusible equipment. There's things like network protectors and that are applied, and for the most part your utilities will own the network protectors. But you're getting into, you have to, here's a good image right here. So this is a relay that we make, and on a diagram you'll see all of these terminologies, and you have to understand what a 50 relay is, a 50R, a 50G, 5051, and all the different things, because and Al said it right. Al says you're getting into the IEEE world, and that, I think, Larry, is a part of one of the things that this task group is trying to address, is when you get into the medium voltage world, everybody thinks that's the IEEE world. That's not the National Electrical Code. The IEEE is the group that governs or manages the NESC, right, for utilities. Sure. It gets pretty technical once you start getting into all of the different types of protective relays that you would have to employ, or you may have to employ.
Right.
Oh, we lost you.
We're not trying to step on. Can you hear me, Tom?
Yeah, you just broke up a little bit.
Can you hear me now?
Yep, gotcha.
So we're not really trying to get into the IEEE world. We're just trying to, we do have installation requirements. I don't think IEEE, they do not get into wiring methods and things like that, and listing requirements. And so we're trying to get into to make sure that an inspector can figure out how to inspect the medium voltage job site, how to make sure that the correct wiring methods are there, make sure that they have the correct listing requirements, and the clearances and things like that. So we're not trying to try to get on anybody's turf, but we're trying to make that the requirements in there are technically sound, they're easy to find, they're easy for the inspector, so we can build on that.
Yeah, and if you're dealing with a medium voltage in a campus environment, an electrical inspector is going to have to understand the current transformers and understand how the relays and what these different symbols mean, and to make sure that we're protecting the conductors and we're meeting the requirements in the NEC for protecting a conductor at its ampacity. You're not looking at a handle rating on a circuit breaker. You're looking at relay set points with long time pickup and comparing that with conductor ampacity values.
That's correct.
And they would typically not get into CTs because that's all part of the equipment, but they would have to be able to understand the relays and whatnot that's providing the protection. Now, Don Ganier's on the line too, and he says, is the 100% rating of and use of the 90 and 105 degree C ampacities related to the fact that medium voltage conductors do not typically connect directly to the circuit breaker? And Don, that could be a part of it. I just know that they're listed for 100% usage. That's the way the listing is and the way the testing is. It very well could be from a termination perspective. I know there's a lot of bus bar in there, right? And if we think about the using a 90 degree C versus 100 versus like a 90 degree C at its 90-degree C ampacity, as opposed to using a 90-degree C conductor at a 75-degree ampacity, is around heat, right? And there's a lot more copper in these medium voltage applications. There's a lot of space, and to an extent, you're correct. They terminate on bus typically. That's bussed into the circuit breaker. So that may play a part of it. But the fact is, it's important to understand you don't have to do that adjustment like you do on low voltage equipment.
Well, I think the other concept is that in low voltage areas, the space is smaller. So, when you get to medium voltage, you always have, the enclosures are larger. There's more room for the heat to escape. And I think that's part of the reason why you can get more with the 100% rating.
Right. And the overcurrent devices are taking on a lot different footprints too. I mean, so Larry, you mentioned a residential home with medium voltage in it, right? That takes a lot of space, and you've got to be careful where you're installing that equipment. Is it out in your application? Was it outdoor equipment?
Like yeah, we had outdoor equipment that we ran all the way over to the dwelling, and then we transitioned over to some medium voltage step down transformers.
Oh, that's pretty good. Pretty good. Is that your summer home?
I wish.
You gotta love it. Yeah. So and then front access equipment versus rear access equipment. There are a lot of things that aren't necessarily code related. To an extent, I guess, you have to think about working space and whatnot, but there are a lot of other calls that you got to make with regard to placement of the equipment, being able to work on it, and maybe where you have to fit that equipment, the size of the equipment, physical construction of it. Looking at some more questions. Will the NEC change the way the terms high voltage and low voltage are used? High voltage is used 47 times and medium voltage is used 14 times. In the NEC, high voltage is lower voltage and then I guess high voltage is lower voltage, medium volt. I guess he ran into the limits there.
But I think most of the time what you're looking at in the NEC, when you mention the term high voltage, it's typically, again, referring to marking signs for people to place high voltage danger warnings.
Yeah. Oh, we know that right now there's what was it, 35,000 volts that is it 35,000 volts is referenced somewhere in there from a high voltage?
Typically, I think that is considered in IEEE world the breaking point between medium voltage and high voltage.
Okay, yeah, you know what?
And I think what happens is when you get above 35 kV, you really get into the transmission level, not the distribution, and so that's when we become high voltage.
Yeah, so this is from IEEE standard 141. 1993. I don't think voltage has changed that much since then. Outside of 600 volts, right? So 600 volts now went to 1,000. But you had medium voltage from 2,400. These are the standard, like, nominal system voltage ratings, up to 69. And then you move into high voltage around 115. So based on 141, it's 69 kV. That's like the end of the extent of the medium voltage. So, but I've seen different numbers associated with that myself.
And I agree. I think there's various different standards that cover it in different ways.
Yeah.
So to say that high voltage starts at 35 kV, it depends. It's on what standard you're using and the language you use.
Right. And they had extra high voltage and then ultra high voltage. That's just and then this was a different reference I found. This was, again, it said 69 voltage, 69 kV, and then high voltage began at 115. So they seem to be, from the IEEE perspective, they seem to be lining in around 69 kV. Okay, so I'm just taking a look at some more of the questions here. I'm excited to see these changes. I think it will really benefit code users. Ryan, so Ryan's liking the whole concept. of this discussion. Totally agree. Felix agrees. I agree, Ryan. This has always been an issue with the NEC. Floodplains consideration, vaults, and other considerations. So I had some images of, when you think about medium voltage outdoors, like in downtown New York and things like that, and down in the vaults, they put those breakers and those switches in submersible type. That's equipment that's designed to be submersed.
Oh, yeah.
You've probably never installed anything like that, have you, Larry?
No, I have not.
Yeah. So, medium voltage can be put into some crazy places. Sometimes it has to live in some places. So, it's something to think about. Why do not we have a table for 75 degree on medium voltage? Is the 75 a bottleneck? So Juan Delgado is asking about the 75 degree, and in reality, the equipment is all 100% rated. It's all rated for you don't have to do the 75. 75 is associated with heat and low voltage equipment.
Right, but think about, if you have a 100 amp breaker, you take those wires, you terminate them on a breaker, and when you do that, those wires are very close to each other, and there's significant heat buildup. So part of the reason why you have to derate those breakers and not load them up to their full ampacity is because of the close terminations and where they're located. If you take something like a 5 kV switch, there is significant amount of space in those, and that space and the way that the equipment's constructed allows you to rate it for 90 degrees to 105 and higher, and that's why it's 100%. The other thing I think is when you're doing medium voltage, as you keep increasing the voltage, you're going to have more and more diversity on the cable. So, if you were at a 20 amp circuit feeding a whole bunch of, maybe 5 or 6 receptacles or light fixtures, when you do that, you're not going to have as much diversity if you have a 5 kV cable feeding a commercial building. So you're going to have a lot more variation, which allows you to use that 100%.
All right. Do you want to take a look at some changes in Chapter 3?
Sure.
What do you want to look at over here?
I think it'd be interesting to show the article. Let's go to 300, and let's go to 300.3.
300.3. There she blows.
Okay, so if you read that, and what's interesting is if you read the original language, it says, and let's look at the old language, it says conductors of circuits rated over 1,000 volts, nominal, shall not occupy the same equipment, wiring, enclosure, cable arrays with conductors or circuits rated 1,000 volts, nominal or less, unless permitted. And then can you go down below? Maybe I'm on the wrong section. Scroll up if you would. Right there.
Oh, yeah. You know what? I can go to the parent text. So 300.3 is all about conductors. You've got
right. And if you look at, go up a little bit higher. Right there, voltage. I think this is, and now if you can just scroll down a little bit. Right there. So if you look at 300.2, it says, wiring methods specified in Chapter 3 shall be used for 1,000 volts, nominal or less. They shall be permitted for over 1,000 volts, nominal or specifically permitted. So the question is, if when you go to Chapter 3 wiring methods and you look at this, you really can't figure out what wiring method applies above 1,000 volts. Some, for instance, like the new class, I think type P cable, which is used for marinas, that cable says you can use it up to 2,000 volts. If you go to EMT doesn't tell you when you can use it. It's silent. PVC is silent. Medium voltage busway gives you a specific voltage level, but not every cable, not every wiring method is treated the same. So it's really kind of hard to find what wiring method you could use. So to try to solve this problem, I think if you can go to the new 305,
The new 305. Hold on. There's your new 305.
So if you scroll, so 305 basically took everything that I think was at 300.50 and later and moved it over here. So if you scroll down, there's a new table right there that they were going to put in 305. And what this does, I think this provides additional usability for the user of the code. And it looks at, it tells you specifically that for rigid metal conduit type RMC, over 1,000 volts, there is no limit on where you can install that type of wiring method. Same thing with EMT. You could put that in theory for a 69 kV cable. If you go to busway is over 1,000 volts, and it tells you where you can find that. Cable bus is only good for 0 to 35,000 volts. And so we're hopeful that this table will give you some more guidance on where you can install these wiring methods.
So when it says not specified, does that mean I could use it on 138 kV?
That's correct. There is no voltage limitation on that wiring method.
Wow. That's interesting.
And again, we didn't have that before, and we think this is a significant improvement.
Right. So David Williams is saying these are great changes for the enforcement community. He also thinks that this is great for both installers and manufacturers, as any segment of the industry against the changes. So he's asking, is any segment of the industry against the changes? And I think I've heard people speak against this change, right, Larry? I mean, I don't think everybody is supporting moving these requirements into different buckets.
No, yes, there's always going to be, no matter whenever you try to do some of these things, you're going to have some people that like the way the NEC is and they don't want to see it change, and I understand that. I think that some of there's a couple installer maintainers that are against this move, and I think there are some code making panels that probably feel that they have the technical expertise to handle these things. And I think what we need to try to make sure that we're progressive, that we try to move the code forward. You look at the changes that have taken place in the electrical industry over the last 10, 15, 20 years. We need to make sure that we're constantly moving forward and trying to move faster than what we've done before. And we'll see how this shakes out. This is a part of the NFPA process, and we will get input from everybody else and see where this goes. But I think that we've had some good support from various people, and I'm hopeful that this will keep moving forward. And yes. I think, like David said, to me this benefits the inspector community because it helps them long term be able to look and enforce these issues. I think it helps the manufacturer. I think it helps him to look at maybe creating more standardization for their products. I think it helps the research and testing folks. It helps them to maybe look at create more of listings to maybe cut down on counterfeit products and things of that nature. And I think it helps the installer maintainer. I think it helps everybody, and I think it helps safety. So I think there's so many reasons why this is important.
Yeah, what I think is a plus. Anytime you make a change to the National Electrical Code, what happens is, no matter what, if materials make it through the first draft, you'll have the IAEI, your NECA, IBW, independent electrical contractors, manufacturers, and everybody talking about what's coming down the pike, and like we're doing right now. So medium voltage, this is a big deal, and we're talking about this right now, which I think is healthy, because even if something doesn't change in the code, or if the code changes in a minor way, you've raised the awareness of medium voltage applications, and you're getting the energy talking about it, which I think does a lot for education and creating more qualified people out there.
Can we get that person that from that person that has that label, education power? Can we get them on a code panel? I like that. Safety before ego. I like that.
You can read that? Yeah, safety before ego. And then he says, what about reconditioning? Medium voltage equipment. Can I recondition medium voltage equipment, Larry?
Yes, you can.
So a lot of this equipment, I mean, here's the thing. When you get into when you get to the larger equipment, like your big power breakers and whatnot, those devices and that equipment gets very large. Replacing that equipment when it gets to end of life is much more difficult, right? Because you just don't go, usually that equipment is probably set in place before they formed up all the doors and all that good stuff. You're not fitting medium voltage equipment into some of these locations after everybody's moving in, and now you've got to put things through doorways and whatnot. So trying to modify that after the fact can be very difficult.
Another argument, going back to Dave Williams' question, some of the arguments against this is the fact that, if someone doesn't understand the medium voltage, then they really shouldn't be installing electrical work.
Yeah.
And they're not qualified. And, I had this conversation today with someone, and, I think that this world is changing tremendously. And so what's happening is, more and more people, there's so much to do in society. People maybe are not so ingrained in the code as they maybe were 20 years ago. You have Nfpa Link, which is a new product that Nfpa developed. They are trying to find a way to get you the information at your fingertips. So if you would type in something in the Nfpa Link website, it will tell you how to wire fire pumps, and it will bring all the information you need all into one or two web pages. So I think that there's a tremendous push to get more and more information to you more quickly. And I think helping reorganize things helps that and helps the way society is moving to be able to find the information quicker.
Yeah. Yeah, I think that's usability. I mean, usability of the National Electrical Code doesn't mean you need a less educated person working on something. It just means that you're helping organizing anything, even for the guy who does it for a living, who's in this and knows medium voltage applications and works on it on a daily basis. Organizing the book differently can really help that individual make sure that what they do is paying attention to the details and addressing the issue. So I can see a lot of value in, I have a hard time figuring out a way to argue against a lot of these changes. I mean, we could talk about, like, to your point, or somebody mentioned earlier about creating a code panel associated with it. That would not be necessarily a bad thing. Trying to put medium voltage expertise on every code panel could be a challenge, because people that do this work from a codes and standards perspective, it's like watching paint dry sometimes. I mean, you got to really enjoy this stuff to get into it and stay with it. So now, Brian Jackson says he used 90.2C to exempt a customer-owned 130 kV substation. And he said he's not qualified to inspect it, and he has no problem admitting it. So a 130 kV substation, that's a big one.
Yeah, and he's exactly right. Some of those areas, when you get up into those large voltage systems, most people probably don't have expertise on that.
Yeah.
But the question is where is that expertise stop? What about a 5 kV system? And we need to, maybe the code needs to be able to just, if the code says we want to have clearance issues, we need to tell people where to go to find that clearance issues. And we might need to tell people need to go to the NESC. So, but we need to kind of, make it a little more technically sound so people know where to look and where to go.
Yeah. So the general direction from a 2023 version of the National Electrical Code sounds like you've got a task group who is moving things around. So you might see if I open up my 2023 code book and everybody is successful, I might see an article missing or sections of an article or parts of an article missing. That doesn't mean you deleted the requirements. That just means you relocated those into a different area of the book. So you have that going on, but then to your point, you also have technical details being addressed in various articles made by some of those individuals who are probably on the code panel or on the task group.
That's correct. That's correct. So there's some little bit of effort behind the background, but the whole effort was really to get things in place to help put more eyes onto it. And you know what? I've sat in on several meetings with people, and they agree that there's some issues. And you know, they said that we need to look at this a little more closely as we move on.
Right. And electrical safety takes a different angle there too. I mean, I don't know. It's probably a lot less likely that you would be working on energized medium voltage equipment, right?
I would agree.
Yeah, that equipment typically is brought down. Now, there's probably now when I look, it's like on some of our equipment, like this equipment here. Hold on, and I'm going to try to mute him because I don't want that to get in our way. But you know, this equipment is medium voltage equipment he's standing in front of, and what he's showing is that the compartment where the circuit breaker is, where the work is being done in separating contacts is in an arc resistant area within this equipment. The exposed door that he's looking at right now is typically closed up. So that entire cubicle in there, if you open that door, you're not exposed to medium voltage. You're only exposed to low voltage in those applications. You might be in there for general maintenance. You might be in there to take some test points off. That equipment is energized. It's arc resistant, but you're not exposed to medium voltage. You're not exposed to the hazard. You still have a shock hazard in there because it's probably 120 volts. But in those applications, you know, when you look at that, at what you're looking at there, you're not going to be doing much in this equipment because it's medium voltage equipment. You've got to make sure that it's de-energized, and there's a lot of relays. There's a lot of remote indication to tell you that equipment is effectively at a zero voltage, meaning doesn't mean you've established electrically safe work condition, obviously lockout, tagout procedures and all that other good stuff. But the equipment is getting more and more complex and more feature rich in helping you understand when it's energized, when it's not energized, and compartmentalized, so that you don't have you're not exposing electrical workers to you know, either intentionally or unintentionally to a medium voltage type of exposure. So I had a couple of these little videos that I thought were kind of interesting. This was on the back of equipment. This again, you know, he's showing the rear of one of our equipment. That's a voltage transformer. That's a PT, so to speak, in the middle. Things get a lot bigger in medium voltage, right? And to Don Ganier's point, you know, this is on the other side of this equipment that he's showing is the front of the medium voltage equipment. So the breakers are in a different compartment from the bus bars. So you're landing your conductor, either you're coming in from the bottom or you're coming in from the top, and you're landing your conductors in those cubicles, which is completely separated from the circuit breaker. And it's on bus bar and an insulated bus bar. So you see a lot of insulated bus in these types of equipment. And working on these is a lot different. But, you know, it's bigger, Larry. I mean, you've got to have the space for this equipment. You just don't. I mean, when you make the decision to go to medium voltage, it's not just, yeah, you know, to your point, I have a long distance to move my power from point A to point B, and the conductors may be smaller, but the equipment sure isn't.
No, the equipment is quite large, and but it is important that we look at these things and make sure that things are technically accurate, because we want them to be technically accurate because we want it to be safe. And so, I would go back to the burial depth, to tell someone, say, hey, you can install a 69 kV cable at 6 inches. It doesn't seem technically safe, and so we want to look at those things, and all this is, I think, it goes to safety.
Yeah, absolutely. Absolutely. So equipment's getting bigger. Safety is paramount. The medium voltage applications are growing. Well, I don't know. Do you think they're growing, or do you think that we're doing medium voltage today in a lot of commercial and customer owned, not utility owned applications that probably is just not getting looked at, or maybe it is getting looked at, but the expertise in that area is probably a lot less than in other applications.
Yeah, I mean, I think it might be growing, and the fact is, Tim Kraushaar mentioned, because of the deregulation, that more and more, because of cost savings, more and more customers and owners and contractors are willing to look at it and install it. And so that's why there might be more demand for the NEC. So I think some of those things have to do with deregulation. And then some of them have to do with the size of plants. Now, if you also think about what's happening also, if you look at the way the big box stores, or maybe big box stores, are kind of going by the wayside, and what are we getting? We're getting a lot of, Amazon.com is growing rapidly, and they're huge distribution. So because we have more distribution access or facilities, it might require more medium voltage for these bigger plants.
Yeah, that's an interesting thought, because if data centers, there's probably a lot of energy usage. I know there's a lot of energy usage, not just from the microprocessor computer perspective, but also from the cooling. I mean, you take a building that's built for what do they call those farms, internet farms or whatever. We have all these different computers, and you have a bunch of data storage and a lot of work going on from a data perspective. It takes a lot of cooling to get that done, and that's probably equipment that's up there in the medium voltage world. I mean, medium voltage motors, the medium voltage motor doesn't have to just be associated with a steel mill or something of that application, right?
Right, and you talk about medium voltage motors. There's medium voltage adjustable speed drives.
Right.
And you think about those, and let's go to Article 430. Article 430 talks about, there's a part, I think part 11, that talks about how you deal with medium voltage. It basically says you just take the full load, and that's how you wire it. You don't need to mark it up 125%. But then if you go to another part, I think it's part 10 deals with adjustable speed drives. Well, when you go to medium voltage adjustable speed drives, it tells you got to go back to 430.6. You got to look at the table, and then you got to mark it up 125%. Well, when you do that, there is no table for those things. And so there, it's kind of disjointed, and that's what we're trying to fix. So again, that goes back to the fact that we're trying to write rules based upon 1,000 volts and less for medium voltage, when we really need the expertise there.
Yeah. Yep, I hear you. Don Gannier was saying that he worked with an electrical engineer who came out of a large chlorine plant where they had 138 kV distribution and local generation, 300 megawatts of local on-site generation. So you think about, that sounds like a utility. Now that would be a privately owned, that have to be inspected, and you've got to have, number one, you've got to have the expertise. And number two, you need to have the requirements in the book to address those applications. And it's not a utility environment where you're dealing with the NESC, you're dealing with the NEC.
Right, and some things in the book were gonna be, might be just simple as clearance issues and safety issues. And as far as choosing the right wire, and some of those things are probably need engineering supervision. So we just need to make sure we spell it out and that people can find it and it's coherent.
Al Teresi, you've heard that name, right, Larry? I mean, you've seen his public inputs, I'm sure.
Yes, we have.
Yep, I know Al's very active in the process. Now, he has a public input, and I'm going to call it up. I believe it's panel 1 because it's 90.2, and he says it's public input number 287. So here it is. This is Al's public input. He is looking at, oh, and you gotta love, installations exceeding 35 kV. He's saying only installations exceeding 35,000 volts is being proposed. NFPA 70 is inadequate in addressing systems above this voltage, even at the medium voltage range, as the code book falls short. I think this code can provide the practical safeguarding of property and personnel at voltages above this range is misleading. As a result, a need is required for this voltage limitation. So he's looking at limiting the application of the NEC to 35,000 volts and less. What do you think of that?
I think it's an interesting comment, and I think Al's public input speaks to the heart of the problem. There was a article that was written someone was trying to write an article, and they were submitting it to the International Association of Electrical Inspectors, and part of their article was saying that the NEC does not do a good job at medium voltage. And I think Al Teresi is saying the same thing. The NEC doesn't do it well. So we have to kind of, take a deep breath and saying, okay, where are we at in the NEC, and are we going to do it well or not? And I think we should. I think there's an opportunity here to make this better, and I think it's for safety. If the NEC covers all these areas that are owned by the customer, then I think we have a duty and responsibility to make it better.
Yeah, and I think that there's a misconception. When I hear 138 kV, a lot of people say, well, that will never occur outside of a utility, but in reality, it does.
Right, and I mean, who knows what's going to happen? The more society goes on, we are having more and more distributed generation. We're having all these little microgrids and things like that, and so who knows what will happen 20 or 30 years down the road. And so we want to make sure that 20, 30 years down the road, we're not so far behind the curve.
Amen. Yeah. Yeah. That's definitely a challenge. And to your point, I like when you say you need to make the code relevant. And I think relevant, I mean, that if there was everybody has their slogans and everybody has their visions. And I think what I've heard you say often in many different aspects, from power over Ethernet to medium voltage to alternative energy sources, what's his name? Robert from Omaha says, you've got energy storage is growing and medium voltage is growing. We've got a lot of opportunity, and it's important to keep the code relevant in all those areas. So it's got to stay up to date.
And think about this, I always say that more and more people, there's a push to put in pulse energy transfer. If you believe it or not, there's more people, putting in patents to try to develop products that are in pulse energy transfer. And I think that people on this program probably don't understand what pulse energy transfer is, but I would encourage everyone to go out and look what that is. But that is the process of, PoE, you can only really put, 100 watts on a Cat5 cable. digital electricity or pulse energy transfer is a way of putting 2,000 watts on a computer cable. So more and more things are going on computer type cables. And the question is, will those get inspected? There's a lot of people that don't want to inspect those areas. They think, that's low voltage, we're not going to worry about it. So, if we continue to ignore those 50 volts and less, then maybe the inspection community is not needed anymore. If we continuously build stuff for above 1,000 kV and we don't understand it, the inspection community suffers. And so I think we need to make sure that all of these areas, we do our job to make sure that they're technically sound and relevant in the future.
Yeah, I agree with you 100%. Yeah, that's an important. It's 15 minutes at a time. Larry. What I started was a 15-minute tech talks on Thursday afternoons. Okay, so you'll notice I didn't put the clock up. I usually throw a 15-minute timer up, and I keep getting reminded by those who stop into these discussions. But I did not advertise this one as a 15-minute tech talk. What did I call it? Technical Thursdays. So,
well, I think, Tom, you have a significant problem in trying to keep things to 15 minutes.
I do. But that's okay. Well, Chris Follen loves it. Al's always here. And I just saw these a lot of these guys on the with Jack Lyons and crew. Massachusetts does their I think it was last night, yesterday, where they were talking transformers and stuff like that. So it's all good. We're all learning something and sharing good information. All right. Is there anything else we want to talk about, Larry? Is there any other items on medium voltage from a code perspective that we think we need to hit?
No, I think hopefully we've hit on a lot of things to help the person here to understand the need to improve the medium voltage, and it was a good educational session.
Yeah, and you know what I'll do real quick? I'm going to do this. If somebody was interested in finding the public inputs, I know it can be confusing to get to the global public inputs, but I'm going to just walk you through how to find the global public inputs for the 2023 cycle, because they're not going to be where you think they're going to be. You go to the next edition, you go to view public inputs, and it's going to ask you to log in, but I've already logged in, so I'm already in there. When you get to this, it's called Terra. This is the Terra view. The Terra's not terror, although some may think it's terror. It's Terra. I don't know why they call it that. But if you looked over here on the left-hand side and scroll all the ways down, you're going to see a link down the bottom. It says Global Input, View Existing. And if you go to Global Inputs, you'll see all of the global inputs. And now, the thing to remember is the medium voltage task group was chaired by Robert Osborne. So his medium voltage public inputs are going to be in, you'll see his name, Robert Osborne. So if I look through and I come down to find something that has his name on it, and you'll see a lot of David Williams. David Williams chaired the, what do they call that? The style manual, right?
Correct.
Yep. So Robert Osborne. So here's one on Robert Osborne. And if public input 3728, you click on view, it brings up the detailed, and this is one that we were already looking at. And here's all of the related public inputs. And then you will find right here, the Word document that I had shown is able to be downloaded from that location. So this is just to help you navigate and find the global public inputs. That's how you do it, and you'll locate those, and you'll be able to download all of those. That's a commonly missed area because I couldn't figure out how to find them, and I don't know if it was Larry or Jeff Sargent or one of those guys were like, you got to go scroll down, look for the global inputs, and you'll be able to download those. So you'll see stuff in there from David Williams, who did the style manual, and all of his globals are asking people to look at aspects of the style manual. And you know, that might be another good 15-minute tech talk with David Williams on a Thursday night. And then you'll see his Robert Osborne's. I don't think I did the photovoltaic, but I didn't do globals. I did specific areas, and you know, I'm learning, Larry, is which is a good point. You know, I put public inputs in primarily so I didn't miss them. But I put public inputs in a lot of these task groups or a lot of the code panels, which says to point to the new articles, and really they can't act on those because we don't know if the new articles are going to be made. So it's I probably in hindsight being 2020, I probably should have focused on just doing the public inputs on creating the new articles or moving things, and if they were accepted in the public comment phase, redirecting all of those public links. But that's, you know, neither here nor there. But I just thought that was an interesting. I was thinking about it. Today, I think I was on panel 13, and we were rejecting a couple of those, and we're using the same rejections. You know, resolve statements is basically that's out of their purview of moving those. So we got Caleb Meeker in out there. We got Nihad El Sharif. I said I won't be hitting the 3-hour mark, so I'm not. So I'm still good. We're at an hour and a half, so that's not bad. And appreciate all of those guys coming out and coming in and watching and providing information in the chat. I'm gonna have to get we're gonna have to get Tim Kraushaar on one of these too. You know, Tim's a pretty sharp dude, and I'd love to get him online as well. We're going to do a program with Nihad El Sharif on ground fault protection of equipment coming up soon. 70B, we're going to do a 70B program. 70B is in the process of changing, so we're going to do one of those as well. Larry, I know you were instrumental too in getting 70B from a you could and you should to a you shall type of document I guess it was a guide or a general practice or something like that to a standard.
Yeah, I went from a guide to a recommended practice, or it skipped over the recommended practice and went straight to a standard.
Yeah.
And if you look at all those things from NFPA, you know, you talked about the three-legged stool of NFPA 70E, the safety standard, NFPA 70B, the maintenance standard, and NFPA 70, the electrical standard. If you look at that, all those are becoming, you know, 70E took off years ago, and it's becoming very important in the electrical industry. And now the maintenance requirement is becoming more and more important. So I think that is also taking off. Excellent.
All right. Well, everybody out there, thank you. Thank you, Larry, for dialing in. I really appreciate it. Great job as usual. Your knowledge is welcomed. And I know my product line is going to be making some more videos, and I'm going to try to get some of those guys online to do some more medium voltage educational pieces, because when you got the energy going about talking medium voltage, like we're talking today in the National Electrical Code, you know it follows as you know, the marketeer in me just starts to come out and say, hey, let's get out there and start talking medium voltage. So, and we had Felix Sandoval on too. So thank you, Felix, for joining us, and everybody else out there. And Larry, thank you very much, bud.
All right, thanks, Tom. Great job.
You too. And we're going to sign off. So thanks, everybody. Take care, stay safe, and please stay healthy. This was another 15-minute tech talk from Tom and Larry. So be good and be safe and stay healthy. All right, we're going to shut this feed down. And Steve Froming was in the house. Look at that. Jeez, oh man. We got everybody out there. All right. I got to figure out how to hit the button and hit end.